Okay, everybody, welcome back. Hope you all had a good lunch. If you didn't, don't forget there's free popcorn next door that you can pop in between presentations. Make sure you have some sustenance to carry on learning this afternoon. So we're moving on to the automotive transport mobility track now. The first speaker is Sona Dardania from IDTechEx. She's going to be talking about additive manufacturing's evolving role in the electric vehicles market. So she's going to be looking at some use cases, adoption strategies, benefits such as lightweighting that we've heard of today, and the challenges for broader integration of additive manufacturing, which is all supported by their data-driven insights and analysis. So, Sona, thank you.
Thank you. Hello, everyone. My name's Sona Dardania. I'm a senior technology analyst at IDTechEx, and just as Jim said, I'm going to talk you through a little bit about the intersection between electric vehicles and additive manufacturing. So just very briefly to understand where I'm coming from. So IDTechEx is a market intelligence company focused exclusively on emerging technologies. That covers a pretty wide range, but two of our big areas are 3D printing, which I cover, and electric vehicles, which we have a whole EV team dedicated towards that. So this presentation was sort of put together based on the combined insights of both our EV side and our 3D printing side. And so first, to start off with a little information from our EV team about the EV market right now. So before I get into the weeds of it, just to start off with what do we call EVs at IDTechEx? We're primarily referring to battery electric vehicles and a certain subset of plug-in vehicles as well as some non-plug-in vehicles. China has another term that they use called new energy vehicle, which is slightly more narrow than our definition of electric vehicle. Secondly, technically, the electrical vehicle market is pretty broad. It covers a wide range of vehicle types, including construction EVs, air taxis, two-wheelers, electric buses, trucks, and vans. But today, I'm going to be primarily talking about electric cars. And the reason for that is IDTechEx estimates that the electric car market in particular is somewhere between 85 to 90% of the EV market, both now and in the future. So this is where the majority of value is within the broader EV market. During today's presentation, I might be using the terms electric cars and electric vehicle sort of synonymously. Now, to talk about the electric cars market in 2024, keeping in mind that this chart includes only the first half of 2024 sales in EV, you can see a little bit of a change going on in the direction of EV sales growth. From 2020 to 2023, there was extremely explosive growth. And even though we still have to count the second half of 2024 in these numbers, which will probably put 2024's numbers overall above that of 2023, it will still be sort of a slower growth rate than what we saw in the 3 years prior. Now, the reason for the slowdown depends on both region. So our three main regions are China, Europe, and the US. As well as drivetrain, there's some differences in performance between sales of plug-in hybrid electric vehicles and between battery electric vehicles, with plug-in hybrids having an unusually good year this year. But for example, if we were to talk about Europe, in Europe, if you exclude Germany, electric vehicle sales have increased 10% year over year thus far. But if you include Germany, it's only increased 1.3% year over year. And the reason for that is in part due to takeaway of a federal subsidy for EVs in Germany, and in part due to sort of a broader macro trend in Germany that's just not really supportive of battery electric vehicle adoption. Having said all of that, IDTechEx, we expect 2024, this sort of year of slower growth, to be a little bit transitory, and that in the long term, EV sales will still increase significantly, enough that electric car sales will surpass that of internal combustion engine vehicles by 2035, roughly. Again, the reason for that is due to different drivers in different regions. If we are going to talk specifically about the European market, then this market is driven most by regulations. There's a specific regulation called the CO2 emissions performance standards for cars and vans. And this is essentially targeting OEMs based off of the CO2 emissions emitted at the tailpipe per se by their cars. And even though that policy is sort of technology agnostic, it's not explicitly saying switch to battery electric vehicles, the reality is that its standards can only be met by the sales of battery electric vehicles and to an extent plug-in hybrids as well. And with that sort of regulation, if car manufacturers do not switch the majority of their sales over to battery electric vehicles quite soon, they would be facing very high fines. And this chart is sort of showing that by displaying the estimated fine in 2025 in the billions of dollars as a proportion of the global profits by individual groups, with VW having potentially a higher fine burden because of the amount of vehicles they sell right now that isn't up to the regulation standards. And this regulation is expected to ramp up in 2025, so next year, and then again in 2030, with by 2035 the goal being to replace all vehicles sold by battery electric vehicles, excluding plug-in hybrids. So this is going to force, at least in the European market, assuming regulations stay the same, auto manufacturers to significantly increase production of EVs very soon. So there are some broader challenges facing EV adoption that's making that task somewhat difficult. Just to sort of set the stage for where maybe AM can play a part, one of the most notable issues is the high cost and also low resale values of electric vehicles. That cost is driven primarily by the cost of the battery within an EV, but there are other components that contribute as well. So they cost still thousands of dollars more than a typical ICE vehicle at the moment, and that's the biggest factor for adoption for the average consumer. Additional limiting factors are a limited availability of different electric vehicle models. Different cities, different environments might need different types of EVs. Additionally, you have issues of EV performance, primarily your range that you can get off of your battery and the capacity of that battery. And going sort of hand in hand to that is the lack of charging infrastructure in many different parts of the world, although that is a big concern in the US with how far apart some things are. Although charger installations are increasing at a very, very fast pace. So manufacturers of EVs might be considering advanced manufacturing methods like AM to see if adopting them helps with these bigger challenges that they're facing. I think, in personal opinion, AM is most compelling where its adoption directly helps address these issues that EV manufacturers are facing. So I guess keep that sentiment in mind as I go through some of the next use cases where we've seen AM thus far. So first and foremost, based off of some of the use cases that I've seen, prototyping for EVs. Prototyping and 3D printing is not new by any means. But I wanted to highlight it because it's still an area for growth and sort of increased penetration for the 3D market as a whole. Many automotive players are actively utilizing 3D printing for prototyping applications. For example, Ford and Formlabs recently came out with a story about using SLS and SLA to develop the Ford Electric Explorer for the European market. But there's still additional areas for 3D printing to really be used in the prototyping application. And this is especially important considering that manufacturers need to increase their EV portfolio as much as possible to sort of suit the demand and the needs of the average customer. So if they want to get EVs out to market faster, they need to design faster, they need to prototype faster, and 3D printing fits very nicely within that need. And so, yes, this is still an obvious field for AM yeah, but it's still an important place where we can still continue growing our own install base of printers and utilization of printers within that. And as just a quick example, I think the gigacasting story that came out last year surrounding Tesla is a really good example of that. Maybe not as obvious, but very important. So gigacasting, speaking generally, is the process of using high-pressure die casting machines to consolidate multiple parts, typically of the EV underbody, into as few parts as possible. And it was really pioneered by Tesla to try and make the manufacturing of their cars as quick as possible. So where does 3D printing fit within that? We're talking specifically about sand binder jetting in this case. So sand binder jetting can be used to prototype the massive mold needed for gigacasting. And it's through that process that you have a significantly lower time to finalize the mold that you need for this giant die casting machine. And because of that, it takes only 2 to 3 months to sort of finish that process, and is estimated to be about 3% of the otherwise prototyping process that you would need to build such a large mold to design that for such a large die casting machine. So it's a very helpful process, obviously, and it could see growth in the future with sand binder jetting's use here. In particular, so Tesla is like the sort of pioneer of this technique, but we know that there are other manufacturers who are looking at it or who have used it. We know GM has looked at it and has used it, I think, for their new sports car, the Celeste, I think. Additionally, we have a few other Chinese manufacturers, NIO, Zeekr, and XPeng, that have been known to adopt it in a specific place in their vehicles. And additionally, there's been a lot of major OEMs, both US, German, and Asian, that have all explicitly said they're looking at it. Now, gigacasting as a whole, not every vehicle is going to be made via gigacasting in the future, to be very clear. There's a lot of barriers for it as an overall process, which would limit sand binder jetting's growth there. It's everything from how capital intensive the process is to the high scrap rate, which they're still working on, a bottleneck in gigapress availability, and also the fact that for big car manufacturers with lots of models, this sort of very streamlined process might not actually be the most effective for them. Regardless, there's still some opportunity there, and I think it's a very good example of how 3D printing as a tool for prototyping can still grow in usage. The second area, which again is not new to 3D printing, but it's worth mentioning, is 3D printing for tools, jigs, and fixtures within a factory. BMW had a story relatively recently about their use of grippers made through 3D printing to assist in their production facilities, as well as other 3D printed parts to machine tools and other things for electric vehicles. And why does this matter? It feeds into the broader macro trend within electric vehicle manufacturing. First and foremost, the need to manufacture more vehicles to fit demand. That's a really critical thing for all car manufacturers. But also, there's the macro trend of electric vehicle manufacturers increasingly bringing things in-house to try and reduce the cost of the vehicle. Again, trying to address that big challenge of EVs are too expensive for most customers. Vertical integration, which happens at all sort of points of an electric vehicle sort of part, whether it be the battery, whether it be other components as well, has been most heavily pursued by Chinese EV manufacturers to date. They've been using this to help push their costs down because the price wars in the Chinese EV market is very much putting pressure on all manufacturers to bring costs as low as possible. For the non-Chinese market, it hasn't been as heavily utilized as to date, but there are pressures in terms of bringing manufacturing closer to home, and this question of increased protectionism and potentially tariffs that surround non-domestically produced EVs. That discussion is particularly starting to take place in the US. That might force car manufacturers to bring as much in-house as possible, and to support that, you need to have effective automation, which is supported by 3D printed tools, jigs, and fixtures. Now, moving on to a specific part of the EV that's sort of unique to that is electric motors. And so this has been an area of exploration for AM, in particular researchers. Electric motors are integral to the EV's powertrain, delivering the power required to move the vehicle. They need high power, torque density, and efficiency to provide good driving dynamics. And in theory, AM could reduce the weight of those motors. It could reduce the assembly by simplifying the number of components in a motor. And it could also allow for more complex designs. So AM does have some benefits that it can offer to the motor market, which is why some research groups in particular have looked at the use of AM within that 3D printing, let's say copper or other metals for, let's say, the rotor, the winding, the housing, etc. Having said that, you're not likely to see mass adoption of 3D printing for electric motors, simply because the current motors that are on the market for EVs are good enough for the mass market EV. For more specific applications, though, 3D printing could be more useful there for the more niche EVs that really need that performance. Additionally, AM could be used to sort of improve the production and improve the time to market of certain types of EVs. So VoxelJet, for example, had an example of using AM to very quickly iterate on a motor housing. And so it can be supportive of mass market electric motors for EVs, probably more in the production assist role, in my opinion. And then you'll have people like Additive Drives who will support production of AM motors, maybe in more niche applications, though. Additionally, one of the things I mentioned was the sort of continued strength of plug-in hybrid electric vehicles, particularly in the short term. It's not the majority of electric vehicles sold by far, that's battery electric vehicles, but they're performing stronger than expected, and IDTechEx continues to see that happening in the short term at least, particularly in areas where concerns about range are really prevalent. So the US is a big issue for that, with a lack of widespread charging infrastructure and the bigger distances that are driven typically in the US. So because of that, you still need your internal combustion engine to be improved to improve the range and improve the performance of those plug-in hybrid electric vehicles. And that's where casting cores for engines come in. So BMW has been a big sort of proponent and adopter of this technology. Again, the use of sand binder jetting to create casting cores en masse that then go inside the casts that are used to make the engine components themselves. And this is for a variety of reasons, primarily to improve cooling and efficiency of these particular engines. And so when you consider that this particular part of the market is still going to exist for a while, I don't think IDTechEx doesn't expect to see EVs overtake internal combustion engine vehicles for a while in the US in particular. This is still broadly relevant to the EV market. And then lastly, okay, so I've spoken quite a bit, and I think maybe I've made it mention this, that mass market electric vehicles and end-use production parts for those vehicles, it would be very difficult for AM to address simply from an economic standpoint. The throughput that you would need for millions and millions of parts is not really done very well by any technology at the moment. So the really big mass market electric vehicle would be difficult for AM to address beyond the production support role. Having said that, there are some interesting applications within the small volume EV market that would still be very valuable for AM to penetrate, or it has already started to penetrate at this point. In particular, luxury EVs, more or less the side of the EV market that can afford to pay for these parts and also have the sort of volumes, like let's say if it's low volume, it's less than 1,000 vehicles. If it's low volume, it's like 1,000, 5,000-ish vehicles. That would not support the investment into the more mature, cost-effective manufacturing technologies like injection molding. And so these vehicles could work very well for AM, sort of continued usage in the EV market, especially for those holy grail end-use production parts. Right now, a lot of people consider sort of all electric cars to be luxury EVs, luxury cars in a sense, because of their pricing. However, we expect the cost of a vehicle to go down, in effect creating a luxury subclass, and the luxury subclass would still be in the millions of vehicles, even if individual models within that luxury subclass are in much lower volume. So that could very much support the use of additive quite well. Okay, so I'm very briefly going to conclude by just mentioning sort of the opportunities for AM that I've spoken with, and then the challenges. Okay, AM, great for faster vehicle design cycles, like the production of functional prototypes, the molds and tools. You also have some lightweighting benefits by supporting consolidation. And with new parts and startups emerging specifically for EVs, those companies will have less of an established supply chain that AM could take advantage of to sort of start being utilized with those companies, especially when they're doing their bridge manufacturing, going from small volume production to higher volume. But the challenges facing AM's adoption within the EV market, of course, the price point of AM, it's not competitive with most traditionally manufactured parts, and it's difficult scaling AM to the volumes required by EVs. That's by far the biggest concern. But then there's also that issue of competing with an established supply chain with very high trust in that market and very high sort of relationships building that supply chain. So that is very difficult for AM to compete with as a whole, and AM has to do a lot to sort of make up that gap and make up that ground. Okay, that's it for me. If you have any questions, feel free to ask me sort of off to the side at the end. Happy to send you the slides if you let me know. And check out the reports that we cover both on the EV market and on the 3D printing market as well. Thank you.